Imagine boarding a train in one country, only to discover that it physically cannot continue into the next. Not because of politics, not because of electricity, but because the tracks are a long distance apart. Around the world, thousands of trains stop at borders for this exact reason. So why couldn't everyone agree on one railway standard? Railway tracks may look identical at first glance, but the distance between the two rails, known as the railway gauge, varies from country to country. Today, about 60% of the world's railways use what's called standard gauge, measuring 1,435 millimeters. But many countries use tracks that are either wider or narrower. The question is, why? To answer that, we have to travel back to early 19th century Britain. The first successful modern railways were built by engineer George Stephenson. His locomotives ran on tracks spaced 1,435 millimeters apart. But here's the interesting part. Stephenson didn't invent the measurement. He inherited it. Coal mines in northern England already used wagon tracks with similar spacing. Those wagons themselves were influenced by even older horse-drawn carts. Over time, one practical measurement simply became the default. And because Britain's railways became enormously successful, many countries copied them. Yet not everyone agreed. Some engineers believed wider tracks would produce faster, smoother, and more stable trains. Others argued narrower tracks would be cheaper to build through mountains and difficult terrain. Instead of one global standard, different countries optimized their railways for different priorities. The result, several railway gauges emerged around the world. Russia chose one of the world's most famous broad gauges. Today, its railways, and those of many neighboring countries, use tracks that are 1,520 millimeters apart. There are several stories explaining why. One popular myth claims that it was designed to stop invading armies from using Russian railways. While the military certainly benefited later, historians generally agree the original decision was based more on engineering advice and construction preference than defense. But once thousands of kilometers of tracks had been built, changing everything became nearly impossible. And even if two countries share the same railway gauge, that does not guarantee trains can cross the border seamlessly. Different countries may also use different signaling systems, electrical voltages, and safety regulations. Even when the tracks are the same width, international rail travel can still require specially designed trains. Railway compatibility turns out to be far more complicated than simply matching the rails. Spain and Portugal made a similar decision. Their railways were built with a wider gauge than most of Europe. As international rail travel expanded, the difference created an unexpected problem. Trains crossing the French border could not simply continue their journey. Passengers often have to change trains. Freight had to be transferred from one train to another. Today, many of Spain's modern high-speed rail lines are built using standard gauge, allowing them to connect more easily with the rest of Europe. Engineers have even developed a clear workaround. On certain routes, specially designed trains can pass through gauge-changing equipment that automatically adjusts the distance between their wheels. Instead of passengers changing trains, the train changes itself. It is an elegant solution, but only practical for certain routes and train designs. Europe was not the only place where engineers chose a different path. Thousands of kilometers away, Another island nation was facing a very different challenge. Japan went in the opposite direction. Much of Japan's conventional railway network uses a narrow gauge of just 1067 millimeters. Narrower tracks were less expensive and better suited for the country's mountainous landscape. But decades later, when Japan built the world's first high-speed railway, the Shinkansen, it made a surprising choice. Instead of keeping the existing gauge, engineers built an entirely separate network using standard gauge. Faster trains needed a different foundation. Japan solved the challenge by building something new, but not every country had the option. Some inherited railway networks built with multiple gauges over decades. Rather than constructing an entire separate system, they chose a different solution. India inherited a railway network built using several different gauges. Over time, they created operational challenges across one of the world's largest rail systems. Rather than living with those differences forever, India began one of the largest railway conversion projects in history. Thousands of kilometers of track have been rebuilt to a single broad gauge, making the network more consistent and efficient. It is a reminder that changing a country's railway gauge is possible, but only with decades of planning and enormous investment. If different gauges create so many problems, why not simply rebuild every railway? The answer is cost. Railway systems include far more than just tracks. Stations, bridges, tunnels, maintenance equipment, rolling stock, signaling systems. Replacing an entire national railway network would cost billions, and in many cases, provide a little practical benefit. Once a country commits to a gauge, it's usually there to stay. Today, railway gauges remain one of history's lasting engineering decisions. A measurement chosen generations ago still determines where trains can travel today. It's another reminder that many of the systems we take for granted were not designed as part of the global plan. They evolve independently. One country, one engineer, and sometimes one practical decision at a time. The next time you watch a train cross the landscape, it's easy to assume every railway follows the same rules. But beneath every passing train lies a decision made generations ago. A choice of just a few centimeters changed how nations built their railways, how goods moved, how people traveled, and in some cases, how countries connect with the rest of the world. History does not just shape our maps. Sometimes it determines the distance between two pieces of steel. If you enjoyed this journey through the hidden history behind everyday roads and railways, there is plenty more to explore. What other ordinary things have fascinating stories behind them? Let me know in the comments. I might cover your suggestion in a future episode. Thanks for watching, and if you'd like to see more documentary style POV driving videos like this, consider subscribing. Until next time, drive safe, and I'll see you on the road.